In this video, we're going to take a look at the small angle approximations. Now, we can use radians to find approximations for the values of sine theta, cos theta, and tan theta. So for sine theta here, our approximation here for sine theta is simply theta, cosine theta, or cos theta. This is given as 1 minus theta squared over 2. And then finally we have tan theta here. And for tan theta, this is given as theta as well. Okay, so these are the three approximations here that you need to be familiar with. They are given in the form of the book, so you don't have to worry about memorizing them. And if you want to investigate why this works, sketch the graphs of y equals sine theta, y equals cos theta, and y equals tan theta, and then sketch the approximation as well. So if you sketch y equals sine theta, you'd also sketch y equals theta against that. Same again here for y equals cos theta, and then sketch y equals 1 minus theta squared over 2, like so. And then finally for tan theta here, you sketch y equals tan theta, and then you'd sketch y equals theta as well. Okay, so these would be three separate graphs here. If you sketch y equals sine theta and y equals theta, what you want to check here is what happens as theta gets very close to 0. Okay, do the same here for y equals cos theta and y equals 1 minus theta squared over 2. And again for y equals tan theta and y equals theta. Okay, like we said, investigate what happens as theta gets very close to 0. You should hopefully recognize why these approximations work. Okay, but there we have it. So that's the small angle approximation. So what we're going to do now is just take a look at a few practice questions here, the small angle approximations. So if we take a look here at question 1, we're given that theta is small and measured in radians, and we're asked to use the small angle approximations to find an approximate value of 4 sine theta plus 2 theta all over tan 3 theta. So if we're using the small angle approximations here, then we need to recognize what approximations we'll need to use. So the trig functions that we've got here are sine theta and tan theta, or tan 3 theta. So in that case, then we need the small angle approximations for sine and tan. So hopefully nice and straightforward. Remember sine theta, approximately theta. Same again here for tangent, so tan theta is approximately theta. Okay, so in that case then, for sine theta, well, if sine theta is approximately theta, that's going to be 4 times theta, which would give us 4 theta there. So for sine theta, let's just write it down, 4 sine theta plus 2 theta. That's all over tan 3 theta. So using the small angle approximations now, we can write this here as 4 theta plus 2 theta. Obviously, we can't do anything with this 2 theta here, so it's just simply 4 theta plus 2 theta. We'll simplify that in a moment. And then this should be tan 3 theta here, so let's try that again. Put that out. And then put the correct argument here, so tan 3 theta. So just be slightly careful here. So the argument of the tangent function here is 3 theta. So my small angle approximation here will be 3 theta as well. Okay, so that's going to be all over 3 theta, like so. Simplify the numerator here. So 4 theta plus 2 theta is 6 theta. That's all over 3 theta. So we've got 6 theta over 3 theta. And all we need to do here now is just simplify. 6 theta over 3 theta, that's the same as 6 over 3. The thetas will cancel. We get 6 over 3, and 6 divided by 3 simply gives us 2 there. Okay. So using the small angle approximations, the approximate value of 4 sine theta plus 2 theta over tan 3 theta is simply 2 there. And there we have it. So that's the solution to question 1. Moving on to question 2 now, we're given that theta is small and measured in radians. So using the small angle approximations, we want to find an approximate value of 2 bracket cos theta minus 1 all over theta sine theta. So because I noticed straight away we have sine theta and cos theta, let's write down the approximations here for sine theta. So that's approximately theta. And then for cos theta here, this is approximately 1 minus theta squared all over 2. Okay. So we've got everything that we need here now to find the approximate value of this expression. Now, in terms of the numerator here, what I'm going to do is I'm going to expand this here with the 2 on the outside. But you don't have to do that. You could replace the cos theta here with its correct approximation. But that is completely up to you. You're not wrong either way. It's just a preference thing. So if I expand this here, so let's just write down the original expression. So 2 bracket cos theta minus 1. And that's all over theta sine theta. So like I said, to begin with here, I'm going to expand this bracket in the numerator. So we're going to get 2 cos theta. Get 2 cos theta, and 2 times minus 1 gives me minus 2. That's all over theta sine theta. So from here now, what I'm going to do is I'm going to use these small angle approximations. So 2 cos theta, so that's going to be 2 lots of this approximation here. That's 2 lots, 1 minus theta squared over 2. Don't forget the minus 2 here in the numerator. What I've got here is 2 cos theta, but cos theta is approximately 1 minus theta squared over 2, and minus the 2 here. And it's going to be all over theta sine theta. But remember, sine theta is approximately theta. So what I've got here is theta times theta, giving us theta squared. Okay, so if we simplify the numerator here, so to do that we just need to expand this bracket here. Well, 2 times 1 is 2. 2 times minus theta squared over 2, that would give me minus 2 theta squared over 2, which is just the same as minus theta squared. I've got 2 minus theta squared, and then don't forget this minus 2 here. That's all over theta squared. And obviously 2 minus 2 would be 0. So in the numerator then we simply get minus theta squared. I've got minus theta squared. And that's over theta squared. So minus theta squared divided by theta squared. In that case then what we're going to simply get here is minus 1. Okay. So the approximate value then of this expression here is approximately minus 1. And there we have it. So that's the solution to question 2. And finally then, if we take a look here at the very last question, question 3, we've got 2 parts, so let's begin with part A. The question says when theta is small, show that 2 cos 2 theta plus tan 3 theta minus 1, all over 3 minus 4, and then this bracket here of sine theta plus 1 can be written as theta minus 1. So here again, just like we saw for the previous question, we need to use these small angle approximations. We've got sine theta here, which is approximately theta. We've also got cosine, so cosine theta, approximately 1 minus theta squared, 2, and then finally tan theta here, which is approximately theta. Okay, so let's just write down this expression here. 2 cos 2 theta plus tan 3 theta minus 1 all over 3 minus 4, and then this bracket here. So what I'm going to do is I'm going to expand this bracket here. You don't have to. You could simply replace sine theta with theta, but I'll just expand it for now. So I've got 3 minus 4 sine theta, and then minus 4 times 1 would give us minus 4 there. Okay. So now we use the small angle approximations here to find the expression here that we're looking for, which is theta minus 1. Then if we start with the numerator, 2 cos 2 theta. So this is probably the trickiest part here, or 2 cos 2 theta, because for my small angle approximation here for cosine theta, the argument is simply theta, whereas here we have the argument being 2 theta. So we'll keep everything outside here of the 2. So I've got the 2 on the outside, which we'll multiply through by in a moment. I've then got 1 minus. Now this theta squared over 2 here, this is for when my argument is simply theta. If my argument now is 2 theta, this would be 1 minus 2 theta squared over 2. Okay, 2 theta squared over 2. We've then got tan 3 theta. Again, tan theta here, this approximation is for when my argument is simply theta. If my argument is 3 theta, then my approximation here will be 3 theta. Okay, so we get plus 3 theta. Then we've got minus 1. That's all over 3 minus 4, so that's minus 1. Then minus 4 sine theta, so that's minus 4 times theta, giving me minus 4 theta. Okay. So now let's simplify my numerator here. So 2 times 1 is 2. Get 2 there. So then I've got 2 theta all squared. So that's going to be 4 theta squared over 2. So that would be minus 2 theta squared. We then times it by 2. We get minus 4 theta squared. We then got plus 3 theta. Minus 1. That's all over minus 1 minus 4 theta. We can't simplify the denominator here. Minus 1 minus 4 theta. So if we simplify the numerator one more time here, obviously you could have skipped this step here and just gone straight away to the simplified form. But I'm going to get 2 minus 1. That would be simply 1. We get here minus 4 theta squared plus 3 theta. And then 2 minus 1 giving us 1. And that's all over minus 1 minus theta. Okay. So how do we get to this expression here? Well, what I want to check here is whether we can simplify anything in my numerator with my denominator. So to do that, because we've got a quadratic here in terms of theta, then we'd hope to be able to factorize my numerator here. And we can indeed factorize this quadratic here in the numerator. But what I'm going to get then is minus 4 theta minus 1. And we're going to get theta minus 1. Okay. Obviously, like we said, we can't do anything with the denominator here, so that's simply minus 1 minus 4 theta. But notice here, it's minus 4 theta minus 1 is the exact same as minus 1 minus 4 theta. Okay. So in that case then, these terms here will cancel. We simply get left then with theta minus 1 as required. Okay. So there we have it. So that's the solution to A. Like you can see, quite a lengthy process to get there, and it is very easy to make a tiny little mistake with these type of questions, but do take your time as you're answering questions like this. So for B then, this part now is quite nice and straightforward. It says hence or otherwise write down the approximate value of this expression here. This is the exact same as the one from part A when theta is small. So this expression here can be written as theta minus 1. Okay, so this expression here is theta minus 1. Now, we're looking here when theta is small. Okay, when theta is small, any terms that involve theta would simply just be, or you can think about it as 0. Okay, we just ignore those values. So in that case then, my theta minus 1 here, well, if theta is small, then theta minus 1 will be approximately simply minus 1 there. Okay, because the theta here, we just simply ignore it, or in other words, you can think about it as 0, get minus 1 then. That's the approximate value. And there we have it. So that's the solution to question 3. That brings the end of this video on the small angle approximations. So in the next video, what we're going to do, we're going to take a look at exam revision for radians.